So question number 10, the velocity time graph of a moving body is given. Find the acceleration, displacement, total displacement. Okay, there are few things that we need to understand about velocity time graphs. So this is a velocity time graph. The first thing is that slope of velocity time graph,
Yes, sir.
delta v upon delta t. This is equal to, can you tell me,
Sir,
what is the slope of a velocity time graph? Can you tell me the slope of a velocity time graph?
sir, delta V upon delta T.
Yeah. What is it equal to? It is equal to acceleration. Any doubt?
No, sir. No, sir.
How do we find the how do we find the slope? So for example, they'll tell you that at time t1 the velocity is v1 and
Yes,
at time t2 the velocity is v2.
V2.
So the slope, this slope, if this is
Yes,
theta, then tan theta is called y2 minus y1 upon t2 minus t1 is equal to m is equal to slope. I think you may not have done trigonometry as on date, so you can ignore this part. Have you understood what I've said?
sir, I have done trigonometry.
Acha, you have done trigonometry. So slope is equal to tan theta, and tan theta is equal to y2 minus y1. So this part,
Okay, sir.
y2 minus
Okay,
y1,
sir.
or let me put this as v2 minus v1. Then it will make more sense. So this is v2 minus v1 upon t2 minus t1. So this is also written as delta v upon delta t, and this is equal to acceleration. Chris, are we clear till here?
Yes, sir.
Okay. So let us look at the question again. In first part, they are asking us the acceleration. In the second part, they are asking us the displacement. So let us discuss the displacement also. See, displacement in a velocity time graph is area under the line. Have you understood?
Okay, sir. Yes, sir.
So let me explain. Let me explain this with the help of this example only. So for example, this question only. So for example, we have this velocity time graph, and
Yes,
they
sir.
have said that the acceleration in part AB, BC, and CD. They want us to calculate the acceleration in part AB, BC, and CD. So if you see
Yes, sir.
AB, the acceleration in AB would be equal to V2. This is V2, this is V1. So V2 minus V1 upon T2. This is my T2, this is my T1. T2 minus T1. Chris, is it making sense?
Yes, sir. Yes.
So this would be equal to 7.5 meter per second square. So this is the acceleration which is in the part AB. So AB is 7.5 meter per second square.
Yes, sir.
Now we are asking to find the acceleration in part
BC.
BC. Here when I calculate V2 minus V1, V2 is 30 and V1
Minus
again 30.
is 30.
Yeah.
Yes, sir.
T2 is 8 and T1 is 4. So this will be equal to 0. So acceleration here would be 0. Is it making sense?
Yes, sir.
Now let us find the acceleration in part CD. So here V2 is 0, but
Yes, sir.
V1 is
Is
30,
30.
T2 is 10, and T1 is 8.
8.
So this will be equal to minus 30 upon 2 is equal to minus 15 meter per second square. Chris, is it making
Yes, sir.
sense?
Yes, sir.
Yeah. So now let us analyze what has happened and let us try to understand, because all these questions would look the same. So let us try to understand what has happened. This is a
Right.
straight line. This is a straight line.
Yes.
See, this is velocity. This is time.
Yes.
Now, what we have understood is, now if you have done trigonometry, you'll understand. If you haven't done trigonometry, don't worry. Once you do trigonometry in detail, you'll understand. So don't worry much about it. See, the slope of this part,
Yes,
the
sir.
slope is positive. When the slope is positive, you'll have acceleration.
Yes,
Here,
sir.
the slope of the line is 0, and that is why the acceleration was 0. And in this part of the graph,
Negative.
the slope is negative. That is why the acceleration was negative, and negative acceleration is also called retardation.
Retardation.
Are we clear?
Yes, sir.
These kind of questions are very important for you from IGCSE point of view. They usually come. Now they are asking the displacement in each part, A, B, B, C, C, D. Now the displacement, like we discussed before, the displacement is the area under the line. It is also called area under the curve. So basically, so for example, simply what it means is that, for example, I want to calculate the area displacement in this part. So I have to calculate the area of this triangle. If I have to calculate the displacement from this time to this time, then this would be the displacement. And if I have to find the displacement from this time to this time, this would be the displacement. Have you understood what I said?
Yes, sir.
So in a velocity time graph, this would be displacement from this time to this time. The displacement from T1 to T2 would be this area, and displacement from T2 to T3 would be this area. Have you understood?
Yes, sir.
You just have to find the area.
Yes, sir.
So let us look at the graph again. So if I have to find the displacement in each part AB, so in part AB, this part, I have to find the area of this triangle. Chris, have you understood?
Yes, sir.
Now the area of a triangle we know is half base into altitude. Are we aware?
Half introducing to height.
Half into base into height.
Yes.
Are we aware of this? If we are not aware of this, let us note this down.
Yes, sir.
So if this is a right triangle, this is the base, this is the altitude. This is called altitude, this is called perpendicular also.
Also called opposite, I think.
This is called height also. And yes, what you are saying is also right. And this part is in a right triangle, this part is called hypotenuse.
Hypotenuse.
So area of a right triangle is equal to half base into height. So this is my base and this is my height. Chris, are we clear?
Yes, sir.
And of course, the simple formula for a rectangle is that if this is my base, this is my, uh, let me call this as,
Less than breadth.
yeah, this is my length and this is my breadth. So area of a rectangle is equal to L into B. So if I am given a velocity time graph, I'm given a velocity time graph, all I have to do is find the the areas. So for example, area of this triangle would be equal to half base. The base would be 4 and the height would be 30. Have you understood?
Yes, sir.
So this would be 60 meter because it is displacement. Have you understood?
Yes, sir.
Now I want to calculate the displacement in part BC. This would be the displacement in part BC.
Yes, sir.
So this would
2
be,
into 2 into 30. Uh, 2 into 30 is equal to
see,
60. 60 we have
from 4
4.
to 8 is 4 seconds. So this will be
Yes, sir.
4 into this. This is 30 minus 10. So this
Yes,
would
sir.
be 120 meters. Have you understood, Chris?
Yes, sir.
And then when they are asking us the displacement of part CD, then we have to find the area of this triangle. This triangle. This will be equal to
Yes, sir.
half base into altitude. Altitude is 30 minus 10, and this would be equal to 30 meter. Have you understood?
Yes, sir.
So that is why they have written the displacement of AB to be 60, BC to be 120, and CD to be 30 meters. Have you understood now?
Yes, sir.
So the two big things that we have learned are that if we are given velocity time graph, the slope is acceleration
Yes.
and the area under the lines, that is the displacement. Have you understood this part?
Yes, sir.
So, but you need to remember that this is what is true for velocity time graph. Velocity time
Yes, sir.
graph. So that is why you need to check the axis, what they have mentioned on the axis. So this should be velocity and this should be time. Because if this is displacement, then this won't be true. Have you understood, Chris?
Yes, sir.
So just look at the graph, the axis of the graph very carefully. And the third part is what they are asking is that find the total displacement. The total displacement would be the sum of this. So we know the area of this, we know the area of this, we know the area of this. We'll just add these three. So 60 plus 120 plus 30. This would be equal to 210 meters. Have you understood, Chris?
Yes, sir.
Now
Yes.
just try to do this question 12 again. Now see whether you are able to do all the parts. Yeah?
Yes, sir.
Yeah.
Sir, yes, I have a question. I don't understand question 12a.
Were you able to
Can
do all the parts?
yes, sir, I will be able to do all the parts.
Okay.
I'm
So
not
try it.
understanding
So try it.
A.
Yeah, just try.
Sir, I'm not understanding A. How, what to do?
I'm sorry, Chris, I can't hear you. Sorry.
Sir, in 12a, what to describe?
Okay, can you send the message on chat?
Yes, sir, one second.
Yeah.